Alright, section 12, corrosion control. Corrosive environment. The corrosive environment found with the most water treatment in plants can be ranged from the mild to aggressive depending on the source of the wastewater, industrial loading, geographical location of the plant, primary proximity to seacoast locations, characteristics of the solids, and area of the chemical to use on site with the treatment, while any structures associated with the WWTPS or wastewater treatment plants are made with the concrete, many with the application required metal alloys and non-metallic materials. In most cases, the corrosion issue should be addressed with the design, storage, and appropriate materials and selection with the corrosion mitigation procedure specified. Being aware of potential corrosion problems during the development phase greatly minimizes the problems that can develop during the construction after the facility for the commission with the operation of the primary design guidance that contains salient decision of the treatment system components typically subject to the corrosion specific compounds concerned there are discussed in chapter World Water Environmental Federation MOP 8 and MOP 8. The chapter 8 is devoted entirely to construction material selection and contains the guidance evaluation plant extreme exposure conditions, the potential for the corrosion deterioration, design consideration, selection material, the construction techniques, Water Environmental Federation MOB FD8, FD5, FD5 on Chapter 4 contains the guidance of corrosion protection in the sewers. The sewers provided with the information on the number of the corrosion issues that should be handled during the design. Additional information that is available with the Air Force Instruction 321054 corrosion control or MO 3047 corrosion control, which should be used with a reference guide with an additional with the information in this section. 1211 underground exposure. Underground exposure includes the piping, steel, ductile iron, reinforced concrete, pre-stressed and concrete, the variation concrete structure, perimeter foundation, manhole, pumping station, clarifiers, characteristics of the soil materials which be exposed, the different bearing with the corrosion performed with the well varying affected corrosion mitigation procedure that were required. All designs required with the geotechnical investigation with the characteristics of the soil, addition with the normal data, develop an investigation to determine the load bearing. Characteristics other soil tests are needed to determine the characteristics of the affected corrosion performance. 12111 soil testing. A number of the soil characteristics will have the direct effect of the corrosion performance of certain materials that are buried in the soil. There are a variety of opinions expressed regarding with the interpretation of soil data. However, the most authorities generally agree on the information presented in Table 21. These data are easily determined during the geotechnical assessment of the plant site with the result of the type of the cement that can be determined for the sulfate resistant condition with the soil resistivity may be used to determine the need for the corrosion protection for the buried metallic pipelines such as ductile iron or steel pipe. Additional information requirements for the cathodic protection and protective coatings are discussed in paragraph 12.3. Alright, sulfites, chlorides, pH, and resistivity parameters and criteria. 1212, submerged exposure. In the water treatment plant, there is considerable amount of the concrete metal with it is particularly continuously submerged in the waste. In most of the facility, the wastewater is nearly normal to pH at 7.0. This is not significantly aggressively in concrete surfaces. However, the most rare metals, ductile iron, carbon steels will corrode in this water unless other methods of corrosion protection are employed. 12121 concrete structures. When totally immersed with the wastewater, the construct structure is generally unaffected with the waste seldom in additional protection. However, whenever the wastewater is aggregated with the overflowing of the wire where falling into the drop box manhole, hydrogen sulfide can be released with the craters which creates an acid environment. The agitation most prevalent in the primary classifier. Other equipment upstream with the primary clarifiers, grit and base and headworks, influence sewer lines. An opening structure of the release of the hydrogen sulfide to the atmosphere will not always create the corrosion environment. However, they cover the overhang with the structure of the other equipment that can be impeded with the release of the hydrogen sulfide by the atmosphere that can leave with the corrosion to the concrete. This often occurs when the odor control of the system are added with the covering equipment that generates the released hydrogen sulfide concentration of concrete surfaces and against the solution. The situation generally requires some of the form of the protection against the acid environmental generated with the hydrogen sulfide. 12122 metallic structures. Metallic structures that are submerged in wastewater will corrode unless they are alloy construction. Carbon steel, ductile iron, cast iron will corrode in this environment, which can be accelerated in aeration basins because of the higher oxygen content present in most of the submerged applications. Protective coatings should be provided on the exterior surface of the carbon steel, with the ductile iron or cast iron. Equipment made for these materials include piping, sluice skating with the wall penetrations, pipe thimbles. Stainless steel alloys are preferred with the immersion of the application corrosion in most applications with the 300 series and stainless steels are preferred. Atmospheric exposure. The atmospheric around most of the wastewater treatment plants is considered to be rather corrosive because of the presence of the hydrogen sulfide's high humidity, particularly with the confined areas. Often the hydrogen sulfide can readily pass into the atmosphere lightly. Corrosion can occur on the plant equipment. However, the release of the hydrogen sulfide to the atmosphere is prevented by equipment covers or other restraints where very aggressive environments can exist, and especially just above the waterline in these areas consideration must be given to providing more restringent materials on the construction protection of substrate with a high performance coating system. Often there are background levels of hydrogen sulfide present and around the wastewater treatment plant. Where there are low, the concentration of hydrogen sulfide can be very corrosive to the various electrical control systems. Because of the large amount of the copper contacts exist in these systems, special consideration should be given to these systems to avoid excessive corrosion. See paragraphs 12.2.4 and 12.2.5. Alright, 12.2. Materials of construction. During the design of the wastewater treatment plant, it is more important to accurately define the conditions surface through the process in addition with the flow of the wastewater through the plant, which shall be examined to identify the area of the wastewater will have the potential to release the hydrogen sulfide. A preliminary listing of acceptable materials of construction should be developed and based on the information present in this section, the specific condition of the wastewater treatment plant. 12.2.1. Concrete structures. Concrete structures have generally given the good performance of most wastewater environmental. The most is important, however, the American Concrete Institution standard practices be followed with the placement of the concrete thickening for the cover over the reinforcement steel. High sulfated concentrate determined to present in either the soil and on the groundwater specific and appropriate type of the cement. Refer to the table of 21 for the criteria specific type of the cement. If the high chlorides are present, it will be necessary to specify a barrier coating on the exposed concrete surfaces. Waterproof all underground structures again for the intrusion of the water of the moisture through the walls. Waterproofing is especially important if the structure will be coated on the inside surface. The hydrostatic pressure through the concrete wall will cause the failure of the coatings on the inside surface in the area known as the suspected exposure of the hydrogen sulfide. The use of the high performance coating system should be specified. See paragraph 12.3.1 for details. 12.2.2 buildings. Customary architectural design buildings may be used with most wastewater treatment plants. Dimensions designs provided with the appropriate steps to be taken to ensure that the corrosion protection is provided with the concrete masonry units, multi-sided buildings, precasting concrete units are acceptable for most applications. 12.2.2.1 Structural seal. Structural seal will require the protective coating and all exposure of the. See paragraph 12.3.1 for the detail of the surface preparation of the coating and selection, preferably complete with the surface penetration application with the primary coat of the fabrication shop before the delivery to the job of the site, and application for the finished coat can then be done in the field. 12.2.2.2 Fasteners. Specify the proper fasteners. The various exposure of the wastewater treatment plant is very important. The following guidelines should be applied with the selecting fasteners. A. Submerged surfaces will vary with the type of the 3/16 stainless steels of ease for the embedded type of the concrete anchors. Both embedded anchor bolts should be specified and coated with the fused bond epoxy to prevent coating with the reinforced steel. The reducing the likelihood of galvanic corrosion and splash of the wet areas to specify the time 3/16 stainless steel for all steel and all fasteners. For atmospheric exterior exposure for the type 304 stainless steel is adequate. For inlet exposure for the high humidity of the hydrogen sulfide present with the specified on the table type 304 stainless steel. Even drying non-process exposure mechanically galvanized steel fasteners are acceptable to refer to the ASTM B695. The specification of the coating for the zinc mechanically deposited on iron and steel. Fabrication metal works unless the wastewater contains several hundred parts per million with the chloride ions. The type 304 stainless steel is adequate for the most application requirement of the stainless steel. Instruction for the use of low carbon and low grade L-grade steel is preferred for the fabrication that have with a considerable amount of welding. All stainless steel fabrication must be properly cleaned and passivated after fabrication. All specifications stainless steel should require the cleaning and passivation and the accordance with the ASTM A380 with the standard practice of cleaning and descaling stainless steel parts and equipment system. 12.2.2.4 Handrail grading. Avoid the painting of the carbon steel with the handrails grading because of the high maintenance associated with the material. The following guidelines apply with these items. Aluminum handrails grading that are acceptable to most areas of the wastewater treatment plant. Stainless steel fasteners hold-on clips should be used. The following the criteria presented with the paragraph 12.2.2.2 handrails should be fastened to the floor's wall with a cast iron base plates. The aluminum components should not be cased or embedded into the concrete base. The high alkalinity of the concrete will cause the accelerated corrosion of the aluminum. Where the aluminum is in contact with the concrete surfaces should be coated with the bituminous coating, but do not leave the aluminum in any other where the lime or limestone or sodium chloride hydroxide caustic is being handled and stored. B. Stainless steel handrails and gratings are also have acceptable or UV the main, much like aluminum ones. However, the stainless steel in contact with the concrete does not require coating. Stainless steel may be used with the line with the caustic area within the chemical handling area. See paragraph 12.2.6 for the use of the caution application with either aluminum or stainless steel for the use of the fiberglass reinforced plastic, and is generally preferably in these applications. 12.2.3. Mechanical terms. Conventional mechanical items may be used with a good performance. The most application of the wastewater treatment plant with the exemption would be in the chemical handling system described in paragraph 12.2.6 for where more corrosion resistant materials are required. 12.2.3.1. Piping. Nearly every type of the piping material has been used for the good service of the WTTPS. However, because of the corrosion condition that they can exist, it is important that the conditions are surface accurate to determine when to specify the piping materials. In certain installations, it may be a requirement that the double containment of the piping may be required. This is especially true with the chemical transfer lines when they are buried. A ductile iron pipe, the type of the pipe that may be used with atmospheric exposure but should be protected with an appropriate coating system. The process used with the produce a ductile iron pipe to develop the process that creates an external surface of the pipe requires the special skills to prepare surface of the coating application. The producer for the ductile iron pipe, they have these skills and should be used to prepare the surface of the primary ductile iron pipe that requires the paint. Copper pipe. Only copper pipes in areas where the hydrogen sulfide is not expected to exist. The copper and alloys are extremely sensitive to exposure to the hydrogen sulfide because of the galvanic relationship between the copper and the ferrous piping. The copper pipe shall be dielectrically insulated from the ferrous piping, the dielectrical unions and flanges. RC carbon seals. Carbon seals may be used with the most application required for the protection against the corrosion in underground surfaces. May be covered with the appropriate system for the underground application for the system of the application cathodic protection. Paragraph 12.3.2. The coating is not necessarily if the piping is in case of the concrete cathodic protection. The pipeline should be electrically isolated for all the other structure of the dielectrical flanges and units above ground immersion for the application required for the appropriate coating system of the paragraph 12.3.1. Thermally insulated pipe should be cleaned primed before the insulation materials is applied with the using the procedure will minimize the possibility of the corrosion under the insulation which can exist undetected. Stainless steel. Stainless steel is frequently used in immersion applications such as for air piping in the aeration basins found under the most environmental type 304 adequate. However, the chloride level of the wastewater are several 100 parts per million. The type 316 stainless steel should be specified as stainless steel pipe is appropriate for certain chemical handling systems. Paragraph 12.6.2, 12.2.6. Non-metallic piping. The piping such as PVC, chlorinated polyvinyl chloride, or CPVC, and the FRP may be successful in many applications. Thermoplastics materials of PVC and CPVC limited temperature resistance should be deaerated at several temperatures increased above the ambient thermal settings. Thermal setting materials, or FRP, have the higher temperature pressure ratings than both materials and significant coefficient of thermal expansion. Therefore, it is critical for the proper layout and support for the restraint to be considered to avoid failure. Pipe hangers. For all piping systems, especially for the pipe hanger to provide with the maximum corrosion resistant with little maintenance, the type of 304 stainless steel is preferred for the most application. However, the FRP with the plastic coated carbon steel may also be used. 12.2.3.2. Gates and wires. Gates and wires should be specified with the provide with good performance immersion application solutions. Gates constructed with the cast iron materials should be protected with the proper coating system of the bronze should be specified with the seating of the wedges with the type 304 and 316 stainless steel from stems and washers and nuts. Specifically, slide gates and wear gates and wire as type of 304 stainless steel. Aluminum non-metallic with stainless steel with non-metallic materials is recommended. The application for the inspection maintenance will not be limited, may be limited if aluminum is used with the coat is surface direct contact with the concrete. Paragraph 12.3.6, 12.3.1 with the coated steel, but is not recommended for the wears because of the difficulty of maintaining paint with the sharp edges. 12.2.4. Electrical equipment. Electrical equipment located in the aggressive atmosphere within the wastewater treatment plant should be provided with the appropriate corrosion protection with the construction of the restraint material of the raceways. The raceways and an atmospheric interior with the application with the aluminum galvanized PVC jacketed steel, wet humid process environmental with the specified the PVC or the PVC jacketed steel hardware accessories should be similar materials bounding hardware metal framing the support of the system may be galvanized aluminum PVC jacketed as appropriate for the services condition repair cuttage of the galvanized PVC jacketed materials with the appropriate repair for the system. Cable trays may be aluminum, the FRP, depending on the specific exposures. Alright, switchgear and motor controls clearances. In switchgear, the motor control clearances, the electrical rooms with the filters, controlled air source with the minimized exposure to the moisture of the hydrogen sulfide, provide vapor phase and inhibitor devices in the cabinets during the construction period of the afternoon operation. The following materials are suggested for these items. Cabinets, factory finish, and usually baked epoxy enamel, boss bars, tin, copper, and aluminum, and connections tinned. Art 12243. Outdoor enclosure and lighting type 304 stainless steel aluminum and the FRP with a piece for the equipment interior of the process area with the moisture and hydrogen sulfide should be used in similar material. Instruments and control systems. Specify that these systems withstand the environmental to which within the exposed generally specific information listed under the paragraph 1224 and will be applicable to instrument and control equipment that direct exposure for the process fluid and chemicals such as the sensors required with alloys to resist the exposure for direct contact with wastewater of the type 304 and 316 stainless steel is preferred for the exposure of specific chemicals to the exposed element should resist the chemical exposure. See paragraph 1226. 1226. The chemical handling system. A number of chemicals may be used with the wastewater treatment plant, but maybe any of the varied aggressive materials should be carefully evaluated with the specifying storage tank, piping, valves, and pumps. Chemical storage facilities are usually required to be within secondary contamination area that are also protected against the specific chemical exposure. Specific coding systems for the chemical containing areas are given in paragraph 1231, table 2 and 2. List preferred material for the construction for the most of the chemical associated with the wastewater treatment plants. For the first material listed is preferred if is required for the chemical storage tank with the wastewater equipment. They should be fabricated within accordance with the National Association of Corrosion Engineers and NACE standard RP 01788. RP-0178, if fabricating detail for the surface finishing requirements, proper design consideration for tanks, vessels to be lined with immersion services. 12261 chlorine gas. Normally, chlorine gas is held within carbon steel equipment that held leading with the vaporizer the downstream of the vaporizing low pressure preferred piping of metallic dry chemical liquid gases not corrosive within carbon steel. However, the one moisture is present into the gas, the very corrosive to all. There must be exotic metals. The most exotic metals require the use of non-metallics. 1222 ferric chloride. The material is acid varied with the corrosion of many of the materials with corrosion beyond the chemical storage contamination area that any surface exposed with the ferric chloride will be deteriorated. Concrete floors and reinforcement steels and concrete will be rapidly attacked and exposed to this chemical. 12263 hydrogen peroxide. Hydrogen peroxide, very strong with oxides, can rather be unstable under certain conditions, but not considerable explosive with rapid decomposition taking place. It can be rather violent, leading to rapid pressurization of the tank and the pipe, and not properly vented with this pressurization can take only the characteristics of the explosion. Before placing a tank in the peroxide surface, it should be cleaned and passivated using oxiding acid with nitric acid. The producer, the supplier of the hydrogen peroxide will perform this service. Sodium hydroxide, the sodium hypochlorite, sodium hydrochloride, sodium hypochlorite storage tank requires special construction for the FRP materials. Both service is recommended with the interior surface available with synthetic material rather than glass fiber. In addition, it is recommended that the post-curing of the tank be performed with the use of hot air and in accordance with the reasons of manufacturer recommendation. All FRP tanks should be fabricated in accordance with the ASTM D3299 standard specification filament wood glass fiber reinforced thermostatic resin chemical restraint resistant tanks, or ASTM D4097 standard specification for the contact molded gas fiber reinforced thermostatic resin chemical restraint resistant tanks. These atmospheric storage tanks should be properly vented and avoid any over pressurization. 12265 concentrated sulfuric acid systems must be carefully designed with understand the aggressive nature of the acid. Although the bare carbon steels may be used with the surface, it was very sensitive to the fluid viscosity of the piping system and will be developed sulfated sludge in storage tanks that is present with the problem. To remove it for the reason with the phenolical lined steel tanks with stainless steel piping is preferred. Details of design the sulfuric acid may be found in the standard RP 0391 material for the handling storage of the concentrated 90% to 100% sulfuric acid at ambient temperatures. Alright, table 22 is the material for construction, chemical handlings, chemical tanks, pumps, and P-pipe and P-valves. Corrosion control. In addition to the proper selection for the construction material for the various equipment, the system associated with the wastewater treatment plant, there are other methods of controlling corrosion, with the exception for the critical service application. Controlling the corrosive environmental for the carbon steel, the ductile iron are still the primary materials for the much of the equipment provided with the wastewater treatment plant, while the carbon steel, the ductile iron, ferrous materials do have acceptable corrosion resistance. In some environments, they still require protection against the high moisture of the hydrogen sulfide that is prevalent. That is not corrosion but the resistance of some of the techniques are required for just aesthetic reasons. The two most common methods to provide with additional protection against the corrosion involve the use of the protective coating for the linings of the ferrous metal surfaces, the immersion and buried application of the protection provided with the coatings is usually supplemented with the application of cathodic protection. 1231. Periodic of coatings. Youth and exemption of the chemical storage contamination errors of the environmental found with the wastewater treatment plant are not exclusive of the aggressively high quality coating systems. And most non-immersion processes environmental, both interior and exterior of the coating system are based on the epoxy primer with the polyurethane finish coat that's preferred with the combination provides excellent color, gloss retention, good durability, minimal maintenance. Interior of the non-process areas are alkali enamel systems will provide good surface for the immersion surfaces for the cold and tar epoxy, straight epoxy, and materials have been used for many years. 12311 surface penetration. Critical to the long-term performance aim for the coating system. The surface penetration industrial standards prepared by the SSPC should be specified to follow the area all coatings application table 23 lists the SSPC surface preparation standards. For immersion application, the SSP SP5 is required for the most process area. The SSPC SP10 is preferred for less aggressively environmental. The SP SP6 is acceptable. Hand and power tools cleaning methods should only be used for the repair and touch-up. Alright, steel structure painting council surface penetration areas. The SSPC SP1 solvent cleaning to remove oil and grease from surfaces. SSPC SP2 hand tool cleaning to remove loose and surfaces contaminating with the non-power tools. SSPC SP3 power tool cleaning to remove loose surfaces with contamination with the power tool. SSPC SP5 white metal blasting cleaning optimum surface penetration required with immersion surfaces. SSPC SP6 commercial blasting clearance cleaning removes most surface contamination used for the less aggressive environmentals. SSPC SP7 brush off blast cleaning remove only loose and contamination often used for the preparation of the concrete surfaces. Alright, table 23 continues steel structure painting council surface penetration standards. SSP8 pickling the chemical cleaning generally used before hot dipping galvanizing. SSP SP10 near white blasting cleaning better than SPA6 but not as good as SP5. SSP SP11 power tool cleaning of the bare metal that generally removes all the contaminants but with power tools. SSP SP12 ultra high pressure water jetting generally clean up in old concrete. Alright, 12312 coating system. The number of the coating system that may be selected depending on the specific type of exposure. Table 24 gives the recommended system based on exposure conditions. Environmental submerged and partial epoxy primer with a gold tar submerged metal with the wastewater epoxy finish coats of atmospheric exposure in all process areas exterior and exterior. Exposed epoxy primer with a polyurethane finish with exposed metal with the non-process interior areas. Rust and hidden primer with the alkali enamel finish. Buried steels pipe enamel cold tire epoxy pipeline tapes. Prep for the any galvanized surface really required painting metal conditioner of the washer primer, touch of the damaged galvanized surface of organic zinc rich primer suitable for the flooring coating for the some area of the skid resistant epoxy aggregated added some chemical resistant coating with the concrete CMU with a high buildup epoxy applied over the surfaces. Chemical CMU wall coating in the less aggressive environmental high building epoxy applied over the surfacers. PVC and FRP surfaces that may be required painting polyurethane for the color coating with the UV protection. For aluminum galvanized surface of contact concrete between similar surface bituminous paint. For anchor bolts and steel dowels finish fusion bonded epoxy. Architectural systems non-process less aggressive environmentals vary for the epoxy. Exposure substrates generally latex, acrylic, latex, and oil base. See Military Handbook 11.10.1 with the paint protective coating for the facility for the details about specific coating system described in this table. 12.3.1.3 Chemical contamination. Ensure the contamination air around the chemical storage are capable of withstanding splash spills with the contaminated chemical. Well, the ultimate exposure is total flooding of the contamination with the chemical. However, the most exposure will be short-term. The type of the 25 gives table 25 gives recommendations. Coating system for the typical chemical used in wastewater treatment system. Exposure to aluminum reinforced polyester vinyl ester, chlorine, non-required gas exposure, ferric chloride, reinforced polyester vinyl ester, fluoride sulfate reinforced polyester vinyl ester, hydrogen peroxide reinforced non-volatile epoxy vinyl ester, methanol reinforced non-volatile epoxy vinyl ester, ozone non-required gas exposure, and polymers non-excated epoxy coating, sodium biosulfate reinforced non-volatile epoxy vinyl ester, sodium hydroxide reinforced non-volatile epoxy, sodium hypochlorite reinforced non-volatile epoxide, sulfur dioxide, non-required gas exposure, sulfuric acid, reinforced non-volatile epoxy, acid brick. 1232, cathodic protection. Supplement the normal deficiency for the coating system. The cathodic protection may be for the coated surface of the basic system may be used the galvanic anode cathodic protection or impressed current cathodic protection. Cathodic protection may be used to protect the interior surface of the structure clarifiers and other metallic equipment, including rake mechanisms and buried pipelines. Tanks may also be protected on the soil side exposure with a cathodic protection. 1232, galvanic cathodic protection system. The form of the cathodic protection utilizes the natural electrical potential between the two metals, magnesium and zinc, are the most common metals that use the cathodic protection. Steel, providing the sufficient amount of magnesium anodes and connected to a steel pipeline, will provide with the cathodic protection for the pipeline for the many years. Most galvanic anode cathodic protection systems for the buried pipelines are installed with the following provisions: the anodes buried within the pipeline, test stations containing the wires of the anodes, pipeline brought to the ground surface, the dielectrical insulation between the cathodic protection pipelines and other structures. The output from the anode's electrical potential for the pipeline should be measured on an annual basis for the certified corrosion specialist and the cathodic protection specialist person may be certified with the NACES International Houston, Texas, effective to the cathodic protection system, and also require the protected pipelines to remain electrically isolated from the other plant structures. 12322, impressed current cathodic protection system. Instead of using the natural electrical potential difference between the two metals, the cathodic protection can be provided with a converting alternate current to direct current with a rectifier unit with the forcing the DC to anode material with the cathodic protection will be provided. Impressed current in the anode system will be more complicated with the galvanic anode system. Typically, components of the buried pipeline may include an AC source of power related to breakers, switches, and wiring rectifier unit to convert the AC to DC, negative cable to rectify with the buried pipeline, positive cable to rectifier to be buried. Anode, the anodes are often graphite and cast iron. The test stations containing wires that are buried in the pipeline after installed connection for the isolated cathodic protected pipeline for the other structures. Annual checks for the impressed current with the cathodic protection system should be performed with the certified personnel. Alright, 12323, design cathodic protection system in accordance with the standard developed in the NACE International. Following standards should be consulted. The RP0169, control the external corrosion underground submerged metallic piping system. RP0572, designing installation, operation, maintenance of impressed current deep ground beds. RP0180, cathodic protection of pulp and paper mill effluent mill clarifiers. Although typically specified for the pulp and paper mills, the standards applicable to the wastewater treatment plant clarifiers. RP0286, electrical insulation cathodic protection pipelines. RP0388, impressed current cathodic protection for the internal submerged surfaces of the sealed water storage tanks. And FRP0296, galvanic anode cathodic protection for the internal submerged surfaces of the sealed water storage tanks. Alright, perform the design, installation, and initialization of any cathodic protection system under the direction of the certified personnel. Additional information regarding cathodic protection may be found in AFI 321054. Alright, Appendix A was the Water Design Guidance Manual for the cross-references. And then Appendix 2 is references. There's a lot of them. And in a bibliography and glossary, and then once again you have your standard document improvement proposal along with every military, every spec